Have you ever wondered if you could actually change your brain? Like physically change it? Today, we're diving into your brain's hidden superpower, neuroplasticity. We're going to see how your brain isn't some static, unchanging thing, but a dynamic network that you can actively reshape your entire life. And it all starts with a question that scientists used to think they had the answer to.
For the longest time, the scientific consensus was, yeah, pretty much. The thinking was that after you hit a certain age in childhood, your brain was basically locked in. The circuits were wired, the connections were set, and that was that. Any damage? Probably permanent. Learning a really complex new skill as an adult? Good luck.
But it turns out that whole idea was completely wrong. The shift in our understanding has been absolutely massive. We've gone from thinking the brain is like delicate porcelain, fragile and fixed, to realizing it's way more like modeling clay. It's malleable, it's adaptable, and it's constantly being reshaped by our thoughts, our actions, and our experiences. And this amazing ability, it has a name.
Neuroplasticity. That's the superpower. It's the core reason we can learn anything new, form memories, and incredibly even recover from brain injuries. But how does this rewiring, this constant reorganizing actually happen? I mean, what's going on down at the microscopic level?
Okay, let's zoom way in and take a look at the brain's tiny construction crew, the neurons. This is where the real magic starts. So get this. Every single time you learn something new, I don't care if it's a new language, a new recipe, or just a new idea, you are physically changing the structure of your brain. You are literally building new pathways, creating new connections between your brain cells. It's wild.
And it all boils down to this really simple, kind of catchy phrase. It basically means that when you activate certain brain cells at the same time, the connection between them gets stronger. The more you use that neural circuit, the tighter the bond becomes. Repetition is literally building a relationship between your neurons.
So, okay, a connection gets made. But how does the brain turn that first, clumsy attempt at something into a skill that feels totally automatic? Well, it's all about paving a neural superhighway. It pretty much happens in 3 stages. First, that initial try is tough. The signal is weak, it's slow, and it takes a ton of mental effort. It feels hard because, for your brain, it is hard. Then, with repetition, that connection gets more stable. But the third step, that's the real game changer. The brain sees you're using this pathway a lot, so it wraps it in this fatty insulator called myelin. Think of it like the rubber coating on a wire. It makes the signal super fast and super efficient.
Here's a great way to think about it. Imagine walking through a tall field of grass. The first time, you barely leave a mark. That's your unmyelinated connection. It's slow going and takes a lot of energy. But if you walk that same path every day, you create a trail. And eventually, you could pave it into a superhighway. That's the myelinated axon. The signal just flies down that path with almost no effort. A difficult task becomes an automatic skill.
And just how slow is that first attempt? We're talking about 2 meters per second. That's why learning something brand new takes so much focus. Your brain is working with this really slow, inefficient dial-up connection.
But after myelination, look at that jump. The signal speed rockets up to around 120 meters per second. That's a 60-fold increase in speed and efficiency. This is the biology behind turning that awkward struggle to learn a new tennis swing into a powerful, effortless serve. Now, this all sounds fantastic, but can we actually see these changes in the brain? Is there solid proof? Oh, absolutely. And it all comes down to a very simple and maybe slightly brutal principle. Use it or lose it.
A now famous study showed this perfectly. Researchers took a group of people who couldn't juggle at all and scanned their brains. Then they taught them to juggle and had them practice for 3 months. When they scanned them again, the part of their brain responsible for that movement had physically grown. It got bigger. But here's the kicker. When they told them to stop practicing for 3 months, that same area shrank right back down. And you can see exactly what's at stake in these scans. We're looking at real, physical changes. The brain isn't static. It's always in flux. On one side, you have things like atrophy, a literal shrinking of brain regions. In the middle, you can see reduced metabolic activity, meaning parts of the brain are just using less energy. Plasticity is the force fighting against that decline. It's the constant process of building and reinforcing those neural superhighways. Our daily actions are always tipping the scales one way or the other.
Now, this incredible power to adapt and change isn't just for learning cool new party tricks. It's actually at the very heart of how our brains can heal and recover from serious injury.
When an injury or a stroke damages one of those neural superhighways, the connection is lost. So what rehabilitation really is, it's the process of using neuroplasticity to build a detour. You're trying to find a brand new route in the brain to replace the one that was damaged. And just like learning a new skill from scratch, it's slow, it's hard work, and it can only be strengthened through active, persistent practice. You're literally rebuilding the brain's network, one connection at a time.
So the big takeaway here is this. Your brain is not fixed. It is a living, changing thing that is constantly being rewritten by your experiences, your habits, and your focus. The paths you use get stronger, and the ones you neglect fade away. This isn't just a cool science fact, it's an invitation. It means you have more power to shape your brain than you probably ever thought, which leads us to the ultimate question. If your brain is constantly being rewritten, who's holding the pen?